Thank you, Chris. Like Chris said, my name is Courtney Davis. I work in the Bureau of Water Supply Protection at the New York State Department of Health as a research scientist, focusing on emerging drinking water contaminants. And I know I got slotted the last presentation of the day, so I'll make it short and sweet. And some of this has been brought up already today in other presentations. So I'm going to focus on EPA's recently published drinking water rule for PFAS, as well as New York State's emerging contaminant monitoring rule. And so EPA finalized their national primary drinking water regulation in early April, and they announced that they would regulate 6 PFAS compounds. So PFOA, PFOS, PFNA, HFPODA, which is also Gen X chemicals, and PFHXS would be regulated individually, and then PFHXS, PFNA, PFBS, and Gen X chemicals would be regulated as a mixture. Now, the regulations are many pages long. I'm going to just highlight some brief key points about the maximum contaminant levels, which is the maximum level allowed, as well as key dates in the compliance monitoring for water systems. I also wanted to highlight that EPA did set the maximum contaminant level goals, which is the levels of which there are no known or anticipated health effects for PFOA and PFOS at 0. In terms of compliance, public water systems would need to begin the initial monitoring period after 3 months of publication, and that happened at the end of April. They're officially published. So that 3 months has started, and there'll be a 3-year initial monitoring period that will end in 2027. Water systems then would need to be in compliance with the MCLs, those maximum contaminant levels, after 5 years of publication, which would be 2029. The PFAS mixture brings up a new concept for the National Primary Drinking Water Regulation. It's called a hazard index, and I'm going to get in that few slides just to show you how that is calculated because it's a new concept for the PFAS mixtures. So this chart has been showed in a variety of form in other presenters today. I'm going to focus in on the maximum contaminant levels, which are highlighted. I already talked about the maximum contaminant level goals for PFOA and PFOS set as 0. And on the right-hand side are the health-based water concentrations, and that's a key level that is used when calculating the hazard index in the mixtures, which I'll get on the next slide. So for right now, I just want to highlight a few things about the maximum contaminant levels. So PFOA and PFOS, if you convert this to parts per trillion, would be 4 parts per trillion individually. PFHXS is at 10 parts per trillion. HFPODA, Gen X, is at 10 parts per trillion. And PFNA is at 10 parts per trillion. Those are the 4 PFAS, sorry, 5, regulated individually. And then there's a mixture MCL. So you have to have a mixture, you need to have 2 or more. So a mixture of 2 or more of PFHXS, PFNA, and Gen X and PFBS would be regulated as a hazard index, which I'll show you how that's calculated, of 1, which is a unitless number. Some key things I want to show is that PFOA and PFOS are not included in the mixture, and also PFBS does not have an individual MCL, and is only included in the mixture. So I just wanted to highlight those key points. So next, I wanted to touch on the hazard index. So what is this? So basically, you're calculating multiple ratios and summing them together to get the hazard index. So those health-based water concentrations that I showed on the previous page are in the denominator. So those 4 PFAS, the Gen X, PFBS, PFNA, and PFHXS, all have health-based water concentrations, which are the level which no or anticipated health effects would occur over a lifetime. So you have 10, 2,000 for PFBS, 10 for PFNA, and PFHX is at 10. What you do is you take the concentration in the water, so say you have 5 and you put that over 10 and you'll get a hazard ratio, and then you sum those for each of the contaminants, and then you compare it to the 1, which is the maximum contaminant level for the hazard index. I'm not going to get into how you calculate compliance. Involves multiple quarters of hazard index calculations, but I just wanted to show the general concept of what the hazard index is and how it's calculated on the face value. And here are some of the key compliance dates again. It has been officially published in late April into the EPA's Federal Register. So that initial monitoring period, which I already mentioned, takes for 3 years. And then after that 3 years is completed, water systems will need to report those, their results in their annual water quality report. So that marks the first public notification effort. And after that, so that's in 2027. And then the actual compliance deadline when water systems need to be in compliance is 5 years, so that's 2029. And that's when MCL violations would start to be issued, not until that 5-year mark. Now I'm going to briefly touch on New York State's emerging contaminant monitoring rule. This stems out of Public Health Law 1112. The Public Health Law gives us authorization and directions to propose, create, and regulate and implement an emerging contaminant monitoring program. The main goal of this is to take a look at emerging contaminants that are potentially hazardous substances that are not currently regulated, and look for them, monitor, and provide public notification if they're above a certain level. There are 5 key parts of the emerging contaminant monitoring program. First step is to identify what is an emerging contaminant. So again, any potentially hazardous substance, man-made or naturally occurring, that's not currently regulated. And then we need to list those. We need to create rule and regulations for those contaminants. And then water systems will test, will obtain analytical data for them. And then based on the level set in the regulations, water systems would need to notify the public if that result is above that level. And then with all regulations, we need to enforce and ensure compliance with the emerging contaminant monitoring rule. So here's the proposed list of the first 2 emerging contaminants lists, and they're all PFAS. The reason they're kind of split up in these 2 lists is the first set is all the PFAS on EPA Drinking Water Method 533. Minus PFOA and PFOS because those are already currently regulated in New York State. So these PFAS would be candidates for emerging contaminants, as well as list 2 is all the PFAS that are on method 537.1, which is another EPA drinking water method, that are not on method 533. So there's 4 additional PFAS, totaling 27 PFAS listed as emerging contaminants. Now this is still a proposal and is not in regulation at this point. Now, once EPA's regulations go into effect in 5 years, those PFAS would need to be removed because now they have a chemical-specific regulation and will not be emerging contaminants anymore, according to the public health law. So last winter, the Drinking Water Quality Council, which is a group of individuals, academia, water purveyors, public, and government that advise on emerging drinking water contaminants in New York State, met. And they passed a resolution to recommend those notification levels for all those PFAS that I just showed before at the method detection level. So that would mean under this program, when water systems sample for those PFAS, they would need to notify the public if it was detected, basically if it was detected, because that's what the method detection limit is. Right now, we're currently trying to develop those regulations based on that recommendation from the Drinking Water Quality Council, and we're trying to leverage existing regulations to ensure there's not duplicate sampling efforts, as well as reduce costs for the small systems. And once that is completed, it will go into, it will be published for public comment, and you can all look at it once it gets published. And that was my short and sweet regulatory update.